Okay, so what we're going to do now is learn how to use pH in calculations. Before I do that, I want to make sure that you know how to use your calculator to do base 10 logs. So for your warm-up, I want you to take the number, take the minus log of the number 2.34 times 10 to the minus 12, and then write down what value you obtain. You should have obtained 13.631. So if you didn't do that, you're going to have to pay attention to some of the examples in this that will explain to you how to use your calculator properly. Now, what is pH? pH is a way to quantitatively express the concentration of hydrogen ions, H+ ions, present in aqueous solution. pH is a log base 10 scale. Now, those of you in Algebra 2 should have had logs by now. The scale ranges from 0 to 14. Each pH unit differs from the next by a multiple of 10. So a pH of 1, it differs from a pH of 2 by a factor of 10 because it's a log scale, not a linear scale. You can take a quick look over here. When this value of pH is very high, like 14, it's basic. When it's very low, close to 0, it's acidic. And when it's around 7, it's neutral. Okay. Neutral, pH 7. Well, what kind of stuff is neutral? I mean, well, water. Pure water is neutral. It's neither acidic nor basic. What kind of stuff is acidic? If you remember from the day that I did the demos that you looked at, where we're measuring pH of common things or acidity and basicity of common things, a good example was lemon juice. And as you're going to see, we can actually put a number on this as you'll learn in the calculations. It's about a pH of 2.2. pH of greater than 7 means it's a basic solution. Now, I think one of the other examples we had that was basic was Drano. Drano has a pH close to 13. Again, you're going to learn how to calculate all this stuff. Now, suppose we're given the H+ concentration. That's the concentration of H+ ions in aqueous solution. And we need to calculate the pH. How do we do this? Step by step. So here's our formula. pH equals minus log the hydrogen ion concentration. The hydrogen ion concentration is reported in molarity, moles per liter. First thing we have to do, once we're given a value, is we need to make sure we hit the buttons in the correct order. So the first thing we're going to do is change sign to get a negative. Then we're going to hit log to get minus log with this little half parenthesis. Then we're going to enter our value, close it, and then hit enter, and we should get a value of 3. So if you did this correctly, hydrogen ion concentration of 0.001 molar should give you a pH value of 3. Now, suppose instead we have the pH value and we want to go backwards and try to find the H+ ion concentration. Here's our formula. When we solve that previous formula for H+, this is what it looks like. Concentration in moles per liter of hydrogen ions would be 10 to the minus pH. So suppose we have a pH of 3. Here are our calculator buttons. First, you're going to select 10 to the x. Now, on a TI-84, that's second log. If you look, there's a little blue 10 to the x right above it. Then you enter the change sign and then the number 3. And it should look like this, 10 to the minus 3. And then when you hit enter, it'll give you the value 0.001. And again, this is a concentration, so it's 0.001 molar. Let's go through a couple more examples. Okay. Suppose we have to calculate the pH of a 0.0355 molar solution of NaOH. NaOH is a strong base. Well, here's the first problem. We're not starting with the hydrogen ion concentration, are we? So we have to remember back to the previous lesson so that we'll be able to figure out the hydrogen ion concentration in this solution that contains base. But even before we do that, we have to realize what strong base means. It means it completely dissociates. So the concentration of the compound is going to be the same as the concentration of the hydroxide ions. So our hydroxide ion concentration is 0.0355 molar. Now, to find that pH, we got to get H+. We don't have H+, we have OH-. So we have to use the ion product constant of water. We have to use this relationship. The concentration of OH minus times the concentration of H plus equals 1 times 10 to the minus 14. So now we plug it in and solve. So the H plus ion concentration is 1 times 10 to the minus 14 divided by 0.0355, and that should equal 2.817 times 10 to the minus 13. And it's molarity, so molar. Finally, we take this value and plug it into this equation. pH equals minus log H plus, so minus log 2.817 times 10 to the minus 13 is 12.550. So this is our pH value for this solution. Finally, if you have a solution with a pH value of 5.76, what's the hydrogen ion concentration? So again, here it's pretty straightforward. We just got to look up the right formula. It's the hydrogen ion concentration equals 10 to the minus pH. Since we have a pH value, we just plug it in, raise 10 to the minus 5.76, hit enter, and we'll get 1.74 times 10 to the minus 6 molar. And that's it.